everyone, we are now in laboratory exercise number 0.003. This is Gauss-Seidel method using MATLAB. The Gauss-Seidel method is the most commonly used creative method for solving linear algebraic equations. This activity will allow students to implement Gauss-Seidel method using MATLAB, FreeMat, Mathematica, or similar software. And the objectives are, at the end of this activity, the students are expected to have been able to construct a function script using MATLAB, demonstrate your understanding and solving system of linear equations, understand and implement Gauss-Seidel method to find solution to system of linear equations using software. Materials needed are MATLAB, FreeMat, Mathematica, or similar software. Feature: the pseudocode can be found in Applied Numerical Methods with MATLAB for Engineers and Scientists by Stephen C. Chopra, 3rd edition, page 289, shown below. The second procedure is demonstrate Newton's method using MATLAB. Calculate the roots of a user-defined functions with the following specifications. Like this, and where A is defined as the square coefficient matrix and B is the vector of constant values, and tol is the tolerance. Display the number of iterations along the x values. So we need to put all these codes on *m script or suite of scripts that is loadable in MATLAB. The MATLAB function should accept the user-defined function as an input argument and produce a variable containing the answer. For example, y. We written function Gauss-Seidel which have 4 arguments, that is a, b, es, and maxit. A is a coefficient matrix, B is right-hand side vector, ES is a stop criteria whose default value is 0.0001%, maxit is the maximum iteration whose default value is 50. We're going to get output as x, where x is solution vector. Now, in further procedure, we are going to check if arguments are less than 2. If they are less than 2, we're going to show an error message that is at least two input arguments are required. Further steps denotes if arguments are less than 4, that means only 3 arguments are provided without any max iterations, then by default max iteration is going to get a percent of 50. Similarly, for arguments less than 3. We are now going to check if m and n will be equal in the input vector A. If not, error will message appear in the command window. Will be matrix must be a square matrix. There are 2 loops here for performing alternative operation with the first elements divided by its diagonal elements, either A11, A22, or A33. The iterations back to the iteration counter to 0 again. So in this while loop, it will continuously updating the x value. So after each circulation, we are going to increase the value of iteration counter. This line 38, the max EA, this condition checks a newly updated value to stop criterion. Now let us check and run the program. Let us make a 3x3 square matrix and set our right-hand side vector. Let us input the arguments Gauss-Seidel A and B. Now we will get the answer. So the answer would be our solutions vector is x1 equals 3, x2 equals negative 2.5, x3 equals 7. For question number 1, suppose the tolerance is set to default by 0.0001%. How would you modify your code such that nmax or the maximum iteration will terminate the program and display the result? The answer is, if now we have the same non-zero values from the first iterations, we can compute approximate error to estimate as each new value is computed at this point. Although the error estimate for the first unknown has fallen by 10% to stop the criterion, and the second is not, hence we must implement another iteration. At this point, we can terminate the computations because the estimates have fallen below. Lastly, what can you conclude from this activity? I therefore conclude that we learned how to do the Gauss-Seidel method of solving a matrix vectors and further enhance the knowledge of using MATLAB. So that will be all for today. I hope you earn a lot. So bye bye.